Greetings. My name is Curtly Lewis. I'm a final year student at the University of the West Indies. My final year project is titled A Survey and a Comparative Assessment of Open and Tunnel Ventilated Poultry Buildings in Trinidad. This presentation consists of an introduction, literature review, methodology, a research review, product design specifications, concept designs, concept selection, final design, a comparison assessment, a discussion, and finally, a conclusion. Introduction. Background. The most produced poultry meat in Trinidad is broilers. Most poultry farmers in Trinidad are associated with open-sided broiler houses. The tunnel-ventilated houses, however, are proven to produce a higher quality and quantity of chickens than the open-sided houses due to its ability that allow fresh and cooler air from outdoors to circulate and decrease the in-house temperature. The open house is proven to have a lower efficiency and a higher rate of mortality as compared to the tunnel-ventilated house. Problem definition. The main problem most poultry farmers in Trinidad are currently facing is heat stress on birds. The average temperature on hot days is 33 degrees Celsius, which is not acceptable as birds require 21 degrees Celsius to prevent heat stress. Project aim. The project aim is to conduct a research review, a redesign, and a comparative assessment of open and tunnel ventilated poultry broilers buildings in Trinidad. The project objectives were to visit poultry farms around Trinidad, design a tunnel and open ventilated poultry house, perform thermal and flow simulation, compare internal conditions and cost materials for the tunnel and ventilated poultry building. Literature review. Broilers were initiated in Georgia, Arkansas, and New England because of its weather conditions. Trinidad and Tobago produces approximately 800,000 broilers per week. The average price per pound of light weight of chicken in Trinidad is $6.50, while the average price globally is approximately $1.05 USD. Most poultry houses in Trinidad are open-sided. To improve houses, a well-designed roof encourages greater airflow ventilation. Installing exhaust fans, cooling systems, and effective material choice can also reduce the internal heat of the house. Methodology. The methodology used to compare this report were conducting a research review, developing product design specifications, generating concept designs and selection charts, calculating and simulating final designs, and creating a comparison assessment of both poultry houses. Data collecting methods. An online questionnaire was distributed and completed by 18 farmers in Trinidad. Farms consisting of open ventilated houses in Trinidad were visited. An interview with a veterinarian in poultry, Mr. Charles, and the president of the Poultry Association in Trinidad and Tobago, Mr. Robin Phillips, were conducted. As a result, issues arose with pest diseases, manual chicken feeders, erosion of materials, and mostly heat stress on the birds. To prevent or reduce these issues from occurring, redesigning the houses are necessary. Suggestions received were effective material selection, reconstructing housing design, switching to an automatic system, and mostly converting open houses to tunnel ventilated houses. Product design specifications. Design specifications were used to generate a customer needs chart. Some examples of customer needs were safety, relative humidity, affordability, ease of repair, performance, and ventilation controls. Design metrics chart previews the metric description such as a floor area, temperature, building height, internal volume, and cost. They were all rated out of 5, 5 being the most important. The needs matrix analysis chart shows a comparison between the needs and the metrics. Finally, the QFD chart is developed. Similar to the needs matrix analysis chart, comparison is showed and rated, but between 1 to 5, 5 being the highest. As a result, temperature and humidity were rated the highest metrics to consider. Concept designs for open ventilated housing. 2 open ventilated houses were designed. The main difference between them were their roof designs. Design 1 has a semi-monitor roof, and Design 2 has a gable-shaped roof with 16 air vents installed to the top to improve ventilation. Design 1 structure is made out of timber wood, while Design 2 structure is made out of steel beams. The both designs' walls were made out of wire mesh, and they both had semi-automatic feeders. The foundation of the designs were concrete, and their flooring were mixed with sawdust and wood shavings. Concept designs for tunnel-ventilated housing. 3 tunnel-ventilated houses were designed. Design 1 consisted of a coolant fan system and automatic side air vents. Design 2 consisted of 16 positive fans at the side of the building. As the air enters the building and meshes together, it is then vacuumed through the top of the roof where 12 negative fans are located. Design 3 consisted of 16 side air vents placed before 16 internal fans. Fresh air is then traveled throughout the house and exits through the 8 negative fans at the end of the building. All of these designs consist of a misting system. Concept selection. Concepts were screened and selected based on their importance to the selection criteria. It was shown that all tunnel-ventilated housing design were the most important and should be considered for the final design. Final designs. The final open ventilated house is 80 meters long, 12 meters wide, 5 meters in height, and holds up to 10,000 birds at a stocking density of 0.09 meters squared per bird. The entire structure of the house is made out of cedar wood. The walls were made out of 2 rows of concrete blocks at the base, together with wire mesh. The structure of the house is supported by cedar wood. The roof is gable-shaped with aluminum zinc galvanized sheets and has 6 air vents. The house has automatic feeding and misting system. The foundation of the floors were concrete, and the floor were mixed with wood shavings and sawdust. The tunnel-ventilated house. The final tunnel-ventilated house design is 80 meters long, 12 meters wide, and 5 meters in height, and holds up to over 10,000 birds at a stocking density of 0.09 meters squared per bird. The entire structure of the house is made from steel beams. The walls were made from 2 concrete blocks at the base, altogether connected to aluminum zinc sheets as the walls. The roof is gable-shaped with aluminum zinc galvanized sheets. The house has automatic fans, feeding, and fogging system. The floor is made the foundation is made out of concrete, and the flooring is mixed with sawdust and wood shavings. simulation, and comparison assessment. The open ventilated house, structural parameters, and weather parameters such as temperature, sunshine hours, relative humidity, and the velocity of air were listed based on the findings from this report. These were shown on the tables below. The final design was modeled and simulated. As a result, it showed that two-thirds of the internal temperature of airflow varied to be 24 degrees to 32 degrees. This is unacceptable for the livelihood of an adult bird. The tunnel-ventilated house structural parameters were listed based on the findings and the calculations from this report. All parameters are shown in the table below. The final tunnel-ventilated house design was modeled and simulated. As a result, the blue represents a 20 to 23 degrees range of airflow throughout the building. This is an acceptable range condition for the adult birds. Cost of material for open versus tunnel ventilated house. As shown, the middle scale tunnel ventilated building surpasses the open by over 49,000 TT dollars. The price of the open ventilated house is high compared to the average cost of the houses in Trinidad due to its area and other functions installed. The cost of labor of the tunnel ventilated building will be much larger as compared to the open. Other expenses that occur are electrical. The tunnel building uses a lot more electricity as compared to the open due to the fans and lights. Though the tunnel building is proven to be much more expensive than the open, it has a greater internal temperature control and is safer than the open building, which is most important. Controlling the internal state of the building boosts the bird's growth and ultimately provides a better quality of birds. The research review revealed that the main issues in Trinidad poultry is heat stress. An effective product design specification was conducted. This generated concepts for the tunnel and open houses. Concepts were then rated. Final houses were calculated and designed on SolidWorks. Flow simulations were performed on each design to compare the internal conditions on SolidWorks. Based on the results, the tunnel ventilated house was able to meet the bird's requirement temperature on a hot day as compared to the open house. The designs from both houses were selected and a material cost comparison assessment was conducted on both buildings. As a result, the estimated material cost of the mid-scale tunnel building proved to be $123,000 TT dollars. In conclusion, the objectives of this report were accomplished. A final design was generated based on a literature review, survey results, and advice from the president of Poultry Association in Trinidad and Tobago. Simulations were completed, and a comparative assessment of the internal conditions and a manual material cost estimate was conducted on the buildings. This report was a success as the aim and objectives were completed. Thank you for listening. This brings the end to my presentation.